Hello, I'm Clement Tang. I'm an associate professor at the Mechanical Engineering Department, and we are at this Upson 1 221 lab.
And I'm Will Semke. I'm a professor of mechanical engineering. We co-teach the mechanical measurements lab here, and we're going to bring you in and tell you all about what we do in this lab. Welcome. So this is the Mechanical Measurements Lab, ME483. In here we expose students to many hands-on activities through a multitude of experiments that we'll go into one by one. As I mentioned, Dr. Tang and I co-teach this class, and we have 3 lab sessions along with 2 lectures in the class. And in this room, primarily we work on different types of traditional mechanical measurement techniques and tools and get the students exposed to those techniques and tools. None of the equipment is extremely hazardous. It's all household type based things, so we don't have any stringent safety requirements that we need to enforce in here, just general safety and household safety and around the house. So
The equipment we don't have any moving parts. We don't have any sharp material flying around, so students do not have to wear safety glasses when they perform the lab exercises.
So at this point, I think we want to show you some of the exercises that the students perform throughout the semester. Again, it's a number of exercises they perform weekly, and then at the end of the class, they do have a kind of a overall experience where they have to design and test their own lab. Ideally, that supports their senior design project. So they have to come up with a good experimental plan and put all the different, what the objectives of the lab are, and all those things. So that's a culminating experience for this lab. So we come over to one of the lab stations. We do have 8 identical lab stations, and we usually have groups of 3 students at a lab station where they get exposed to the different common tools a mechanical engineer might encounter during their employment. I have the first lab. I start with a lab I call Circuits Practicum 1, where essentially the students just get exposed to the different equipment in the lab. They start in here just using a simple soldering iron to do an inline solder joint, so they all get exposed to soldering operations. Then we go into using some typical electronic equipment. We have IDL 800 digital lab. This is just an experimental board where the students can assemble circuits. And what they do is they use this for a power supply. It is low voltage. The maximum voltage is 15 volts DC, so it's very low voltage. This also has a digital multimeter and a function generator on board. So they use this tool. They use this tool along with the Agilent. And our Agilent has the capability of measuring many different electronic signals, and they use this to do AC and DC measurements for the lab. They're also exposed to an oscilloscope, where they do AC measurements. These measurements are done on just standard electronic components, resistors, capacitors, integrated circuits, that sort of thing. I should have mentioned each lab station is equipped with a toolkit that has the standard hand tools that they'll need to conduct the labs. So the first 2 weeks are focused on, or the first 2 labs, I should say, are focused on electronic components. And I'll turn it over to Dr. Tang.
And so the third lab that we work on is on data acquisition. So for data acquisition system, what we have is we have this MIDAC at each station here. This MIDAC is a data acquisition system with 2 channels where the students can get analog signal coming in. So what they do is they can set up a function generator from this IDL and set the different frequencies. And with different sampling frequency, they find out when aliasing is happening. So where the students learn about aliasings, the Nyquist frequencies, using the IDL as function generator. and this as a data acquisition system. And then of course they test it with the oscilloscope to make sure that the signal is what they're measuring when aliasing is happening, when it's not happening. So the students learn about all these different signals that they produce and signals that they recorded. The next one I think would be Dr. Sankey's lab.
Yeah, the next lab they do is actually a material testing lab and a design of experiments lab. Unfortunately, I can't let you see the universal testing machine as it's currently out for repair. We had some damage done to it, so we hope to have that up and running soon. But we use the universal testing machine to test polymers, and then we vary the parameters at which we test, and then we do a design of experiments technique to figure out which parameters have the largest impact on the strength. So they look at materials, they also learn a design of experiments methodology. Dr. Tang?
So the next lab is on time constant. So for time constant, we have two types. One is the your typical RC circuit, a resistor and capacitor time constant. So the student will charge the capacitor and discharge it and measure the time constant that way. And also the second one, the time constant, is on a thermal system where we heat a aluminum rod using a power supply here. And once we heat the rod to a certain temperature, as the initial temperature, we'll let the rod cool down, and the student will take the temperature measurements of the rod cooling down and then find the time constant for that rod in cooling. That would be your Lamb capacitance method for the time constant. So the student learn about various systems, a electrical system, a thermal system, and each of them carries their own time constants physically. Then after that, I have my temperature measurement lab. This is where I show the student how to instrument different temperature sensors. We have an RTD. Each station will have one RTD where they measure the resistance output at different temperatures. So we have an ice bath where the student have a cup of ice and measure the ice temperature with the resistance coming out, and then we have a boiling water to measure the boiling point of water, and again the resistance coming out from this sensor. So the students learn how to record the data for different resistance output from the RTD and correlate that to a known temperature. We also have a thermocouple where the students would form thermocouple joints and use that to measure the voltage output from the thermocouple. So the student learn about two different temperature sensors and implement that later on for their student choice lab.
After the temperature sensor lab, we also then go into a vibrations lab. They mount an aluminum beam in a solid structure. We put an accelerometer at the tip of the beam, and then we excite that beam with various impact loadings. And then we use our dynamic signal analyzer to look at the natural frequencies of vibration and correlate that to the predicted natural frequencies that they calculate prior to lab. So they get to use accelerometers, and they get to use a dynamic signal analyzer to see what those tools can do for mechanical measurements. And Dr. Tang?
And our next lab will be on pressure measurements. So pressure measurements, what we have is, we have a couple of things here. So we have a digital manometer, where the students will use this digital manometer to calibrate a piezo-resistive pressure sensor. A piezo-resistive pressure sensor is something that it's a semiconductor material, and then at different pressure, it puts out different voltage output, and so the students will measure that voltage using the setups they have in their stations, the voltmeter, the multimeter, the Agilents to measure the voltage output. We also have this is a transducer. This transducer has a diaphragm in there. We pressurize this using this dead weight tester. This by putting different weights on it with a piston, with a cylinder and piston, it would put out a known pressure on the system, and then the students will measure the output of the voltage and calibrate this sensor that way. So we teach students how to calibrate pressure sensors and use that to measure pressure drops and also static absolute pressures as well. I think that the next one is, after the pressure, is we have the strain gauges. So the next two strain gauges is, I think this one is there's a strain gauge on the rod. The students will apply a strain gauge as a cantilever beam, and then the students would do some analysis with some stress analysis on it, and then compare the deflection output measured by the strain gauge on this beam here. And then after that, with the strain gauge, we have what we call the PopCan lab. Again, using a strain gauge, except now we use a rosette strain gauge where the student attach the strain gauge on a PopCan, and then once it's attached, the students will pop the can and then measure the internal pressure. So with the strain gauge finding the principal stresses and then the principal strain, the students would use that information to calculate the internal pressure for a pop can. And then after that will be our student choice lab.
And so, yeah, that's a total of 7 different lab activities throughout the semester. And then it culminates in the student choice lab. As I mentioned, that is a lab that we hope can support their senior design projects and to get experimental information. It really gives the students the opportunity to formulate how to create an appropriate lab to get useful data. And that takes the last 4 weeks of the class to carry out that experiment. And that's where we end. In that experiment, they're available, everything in this room is available for them to use, along with any other specialty equipment that they might have from their projects. Again, there's a mechanical measurements lab. We're just trying to get the students exposed to many different pieces of hardware that they might encounter as practicing mechanical engineers, and a lot of the techniques in using for data analysis. Again, no hazardous equipment, nothing to be overly concerned about, just standard safety procedures and using household materials.
So the students learn how to instrument those sensors, the circuitry for that, and then of course we teach a whole bunch on uncertainty analysis as well, which we think is very important for the student to estimate uncertainty in the experiment. So the student get an overall view of how mechanical measurements is done by researcher as well as practicing as engineer.
So we hope that gives you a good overview of what happens in Mechanical Measurements Lab. Thank you.